Alright, so in this video we're going to, hang on, wrong paper. So in this video we're going to go over a factoring technique called difference of two squares, sometimes called DOTS. Right, so difference of two squares basically says it's a very simple factoring technique. If you have two things being subtracted and both of them are perfect squares, you can write them this way. Square root of the first thing minus square root of the second thing times square root of the first thing plus square root of the second thing. Now, technically you can do this with any two numbers being subtracted, but it's only really useful when the two things you're doing are perfect squares. Now, the prerequisite, what you're going to need to know before going into this video is just, I would suggest knowing how to factor by GCF method, greatest common factor method. And also, you should know how to do square roots and do square roots of variables. So let's first go through this example, right? So we have something minus something else. We have x squared minus 25. Both of them happen to be perfect squares, so difference of two squares works fine for this particular question. All right, so we're going to do square root of x squared minus square root of 25 times square root of x squared plus square root of 25. Okay? Now what's square root of x squared? Square root of x squared is just x. Square root of 25, 5. And similarly here, we also get x as the square root of x squared, and then plus the square root of 25, which is 5. So that's the difference of two squares. Now let's go through a few more examples, varying in complexity. All right, so example 1. We're going to do 9x squared, minus 1. Now, first we're going to check, all right, are we dealing with a difference, a subtraction of two things? Now we're going to look, are both of these perfect square? Okay, I know 9x squared is a perfect square because 9 is a perfect square of 3. X squared, square root of that is just x, so we're good with the first thing. Is the second thing a perfect square? Well, square root of 1 is 1, right? 1 squared is 1, so we are dealing with two perfect squares, and now we can do our difference technique. So it's going to be square root of the first thing, and eventually you're going to get to a point where you don't need to do this middle step. I'm just over-explaining it for the point of teaching this, right? So square root of the first thing minus square root of the second thing times square root of the first thing minus square root of the second thing, or it's plus square root of the second thing. We need a plus and a minus, right? One of each. And now to go through with it even further, actually taking the roots. So square root of 9 is 3, square root of x is x, so square root of x squared is x, so square root of 9x squared is 3x. Square root of 1 is just 1. And then similarly, square root of 9x squared is 3x. And square root of 1 is 1. All right, now let's go through a second example, right? Slightly, a little bit harder, or what looks a little harder. Really, you're just doing the same technique. And the ease of this really comes down to recognizing when you have perfect squares, right? Any variable where the exponent is an even number is a perfect square automatically, right? And you should also be familiar with a few of these smaller perfect squares, like 1 squared is 1, 2 squared is 4, all the way up to 12 squared is 144, right? That you should really be familiar with. So the next example we're going to go through is about 36x squared minus 100x squared, or 100y squared, y to the fourth. Yeah, y to the fourth. Okay, something like this. Now, it's okay, we're dealing with two different variables, and they're in the first thing and the second thing. That's fine, as the only conditions that we have to meet is we have a difference of two different things, check. Is the first thing a perfect square? 36 definitely is. Square root of 36 is 6. X squared definitely is, right? Even number. I know square root of x squared is x. 100, that's a perfect square. And y to the fourth. Y to the fourth is a variable with an even number exponent, meaning that is a perfect square, which is why I said earlier, you need to be familiar with how to do square roots of variables. So now that we've checked that these two things are perfect squares, let's actually do the difference technique, difference of two squares. So 36, square root of 36, x squared. And this will be the last time I do this in between technique. Minus square root of 100 y to the fourth. And then I didn't leave myself enough room, but I'll write it down here, multiplied by square root of 36 x squared plus square root of 100 y to the fourth. All right? So now let's simplify this and actually take those roots. So square root of 36 is 6. Square root of x squared is x minus square root of 100, which is 10. Square root of y to the fourth is going to be y to the second. All right. And then similarly, we're going to get here 6x plus 10y squared. Now you should be noticing a pattern. These two numbers are always going to be the same, right, in each of them. The only thing that changes is the addition sign in one of them and the subtraction sign in the other. All right, so let's go through another example. Okay, so this one, I'm going to make it slightly a little more difficult. I'm going to just use higher exponents. It makes it look more difficult, even though in reality it shouldn't be. It's the same technique, really. This should seem repetitive and hopefully a bit like easy and boring at this point. 9x to the 10th minus 64y to the 24th. So quickly do our checks. I know 9 is a perfect square, x to the 10th is a perfect square because of the exponent rule I named before. 64, perfect square. Y to the 24th must be a perfect square also. So all I'm going to do is that's going to equal. Now I'm not going to do that in-between technique I was talking about before. I'm just going to go straight to the actual answer, right? Because this eventually will become second nature where you don't really need to write that middle step out. So square root of 9, 3, square root of x to the 10th is x to the 5th, minus square root of 64, it's 8. Square root of y to the 24th is simply y to the 12th. And I know the next thing will be just using the same numbers with an addition sign instead of a subtraction. So 3x to the 5th plus 8y to the 12th. All right, hopefully this is getting a lot easier. So let me go through one more example before I want to give you a couple of unique cases, right? A couple of cases where, you might not see often, but they'll still come up. So first, let's go through this. So our next example is 6x squared minus 96y squared. Okay? Now, we have the difference of two things. But if you notice, we have two things that are not perfect squares, right? 6 isn't a perfect square of anything, and neither is 96. So what could we do? Well, you always want to look for, different options you might have in a question. This is really showing you techniques. I'm not sure exactly the type of question you could be faced with, but I mentioned earlier that you should be familiar with GCF method. Okay, there's a common factor in both of these, 6. 6 goes into both of these numbers. So what happens if I take out 6 from both and rewrite this as 6 on the outside. And then 6x squared divided by 6 is just x squared. 96y squared divided by 6, well, that's just going to get you 16y squared. Now, you might notice that, hey, this thing here, these two things are perfect squares, so we should be able to do difference of two squares with this term, right? So let's go ahead and do that. Now that we've factored it to a place where we can actually use our difference of two squares technique. So just to give myself more room, I'm going to rewrite this on the side here. All right. So 6 stays on the outside, right? That's not really a part of what we're doing. Now we're going to do square root of the first thing. Square root of x squared is just x, minus square root of the second thing, which is square root of 16y squared, should just be 4y. And now we need the second set of numbers. So it's same numbers, x, and instead of minus 4y, it's going to be plus 4y. All right? So that's just an example of something that you can do difference of two squares with, but it's not immediately obvious. You need maybe one extra step in the beginning. All right, so let me go through a couple more examples. So the next two things I want to go with is just something I want to note. So let's take this example of 144 x to the fourth plus 81 y to the sixth. All right, so let's say I want to do difference of two squares with this, right? They're two numbers. We have a 144, which is a perfect square, x to the fourth, perfect square. So that means 144 x to the fourth. It's also a perfect square. 81, perfect square, y to the sixth, it's a perfect square. So 81 y to the sixth is a perfect square. So if I have two numbers and both of these are perfect squares, you'd think, okay, I can do difference of two squares. Keyword is it's difference of two squares. This isn't a difference. So this thing cannot be done using dots. Okay, that's super important. Always make sure that it's two numbers being subtracted, right? It's difference of two squares. That's very important. All right, and next I'm going to go through just another example that you can technically do and really ignore this example if you had trouble with kind of some of the earlier stuff, because this is a concept that you might not necessarily be tested on. Okay, so let's say we have something like 7x minus 13. So we have two numbers subtracted, but I think you can clearly see that neither of these are perfect squares, right? So you might be surprised to know that you can still technically do difference of two squares with them, right? Right in the beginning, I gave you essentially the formula, right? If you have a minus b, where a and b are any two numbers, is that in frame? Yep, where a and b are any two numbers, then you can write it in this way: square root of the first thing minus square root of the second thing times square root of the first thing plus square root of the second thing. The only thing is, it's really only useful when you're dealing with perfect squares. You know, especially if you're in Algebra 1 or something like that. But you can still rewrite this as 7x, square root of 7x minus square root of 13 times square root of 7x plus square root of 13. If you multiplied these, right, if you just FOILed these, you would get back to this answer, right? So, yeah, it follows the same equation for difference of two squares, although it's just not exactly right now for you helpful. All right, so that was the general overview for difference of two squares, right? Really simple factoring technique, but very useful. Key takeaways is remember this kind of formula, remember this rule. You have two things subtracted. Check to see if they're perfect squares. If you can, then it might be helpful to do difference of two squares. Okay. Another important takeaway: keep in mind that you can only do it when you have a subtraction sign here, right? An addition sign you can't really do it with. But other than that, it should be fairly straightforward. If you have any questions, you can throw something down in the comments.